Hello, Honors Algebra. Mr. Lawrence here with just a quick lesson. We're going over some equation solving techniques. And we're going to look at this 4 quick problems here. Number 1. I know some of you might just want to jump into this problem, but before you do, I want to draw attention to the fact that we have a 5x here and a positive 3x here. And they're on the same side of the equal sign. Don't make this hard. Keep it simple. 5x and 3x is 8x. Minus 2 equals 6 plus 4x. Okay? I know you know that. That's combining like terms, right, Nelson? You got it. All right, so now I have x's on both sides of the equation. I don't like that. I'm going to take one of them away. It doesn't matter if I take the 8x away or the 4x away, but I'm going to have to take one of them away. If I take the 8x away, I'm going to end up with a negative x. Not that there's anything wrong with that, but sometimes I might lose that negative and then therefore get the wrong answer. Typically what I will do is take away the smaller coefficient. So 4, the coefficient is the number in front of x. I'm going to take away 4x from both sides. When I do that, the coefficient on x will be a positive term, and that will allow me to not have to worry about a negative. Sometimes in my haste, I forget about negatives. All right, so I like to minimize the opportunity I'm going to make the mistake. Now we just have a simple two-step equation. I'll add 2 to each side. I'll get 4x equals 8, and x equals 2. I'll bet Hannah can tell you that I divided each side by 4. And I could put that in the original equation, check it. 5 times x, 5 times 2 is 10, plus 3 times 2 is 6, minus 2. Looks like this side is going to end up being 14. Over here, I'm going to have 6 plus 4 times 2 is 8. 6 and 8, 14. They are equal to each other. I must have done the problem right. Big check for me. In fact, I think I need a giant star because I did so well. Ooh, or lots of stars. Okay, let's scroll on down to problem number 2. Here's one. I know Max is thinking I'm going to have to find the LCD and then use it somehow. And Max, that's a great thought, except I'm going to go ahead and simplify by getting rid of this negative 5 first. Add 5 to both sides. It's a relatively easy thing to do. And when I do that, I'm going to have 2/3 x equals 1/4 x plus 11. All right. Now, the LCD. I'm going to look at all the fractions, all their denominators. 3, 4, and 1. The smallest number, the least number that both 3 and 4 goes into is 12. So I'm going to multiply each term by 12 over 1. Multiply this term by 12 over 1. Multiply this term by 12. Doing so will allow this to turn into a 1 and that to turn into a 4. I'm going to simplify the 12/3 and get 8x. Over here, the 4 will turn into a 1. The 12 will turn into a 3. I'll get 3x. Now, 12 times 11. You may not know this cool 11s trick. See, check this out. I'm going to put a 2 down. I'm going to put a 1 down. 1 plus 2 is 3. 132. Isn't that a cool trick? Here, try it with this. Try 42 times 11. Okay, it's going to have a 4. It's going to end in 2, and 4 plus 2 is 6. 462. Who needs a calculator? Now, the only thing you got to be careful of is if you try it and there's carrying involved, like 85, say. Okay, times 11. I want to say it's going to end in 5, and I'm right. I think it's going to begin with 8, except I know that 8 plus 5 is 13. I'll put the 3 down, carry the 1, so I'll really have 935 because of carrying. Really cool trick for 11s. All right. Here's one. I can't subtract that 1 off. I mean, I could, but it doesn't do anything to subtract that 1 off. I don't like the 3 here. I don't like the 5, kind of mucking things up. I do know that the LCD of 3 and 5 is 15. So I'm going to multiply each fraction, or each term, I should say, by 15. And if there's a fraction there, I'll multiply by 15 over 1. I'll simplify the 15 thirds, turn that into a 1, turn that into a 5. Okay, and then I have to distribute. Notice I didn't combine the 2x minus 5. And I'll bet that, that Alexis could tell you that you can't simplify 2x minus 5 because they're not like terms. One's an x term and one's not. So I can't put them together. I can't make banapples. So I'll have 10x minus 25. I have to do this. Nothing's going to simplify, so I'll get a plus 15. And then over here, 5 will divide and simplify 15 fifths. I'll have 3 times 3 is 9. And don't forget my x, right, Sydney? Don't want to ever forget the x. I can go ahead and combine these like terms right here. Make it a little simpler. Get 10x minus 10 equals 9x. And in this case, because I like to do less steps, I'm going to go ahead and subtract off the 10x. And I know I said I usually do the smaller one. I'm not contradicting myself. It's just that doing it this way allows me to do it in one less step, and I like doing the least number of steps I can. Some of you want to add 10 to both sides and subtract 9x to both sides. That's fine, but I know the more steps that I make, the more likely it is I'm going to make a mistake. All right, so right now I have negative 10 equals negative x, but I never want to have a negative x. I'm going to divide both sides by negative 1. Why am I dividing both sides by negative 1? Because it's like I have a negative 1x right there. So I'll divide by negative 1, and therefore x will end up equaling positive 10, and there I go. And if I check my answer, I know I didn't check on the last one, but I can check it on this one. 2 times 10 is 20. 20 minus 5 is 15, and 15 divided by 3 is 5 plus 1. So the left-hand side turns into 6. The right-hand side, if I have 3 fifths times 10 over 1, the 10 fifths will simplify to 2. 3 times 2 is 6. And look at that, I get a 6. So it checks, and this time I am going to give myself a very large star. You just watch me. And here we go. Oh, look, we're in luck. It's a rotating star. Rotating neutron. We may have a wormhole. Help us escape. Oh, no. Don't get dizzy. All right, one last problem for you all. Here's one. Nothing to do on the left-hand side at the moment, but I certainly will distribute on the right-hand side. I could, if I wanted to, divide on the left-hand side by 2 on both terms, but I think it's easier to distribute. So I'm going to get 6x plus 8 equals 6x minus 8. And I noticed something already, but you may not see it yet, so I'm going to keep doing. I'm going to subtract 8 from each side. Okay, and I'm going to end up with 6x equals 6x minus 16. And then I'm going to subtract 6x from each side. Now, be careful here. A lot of people make the silliest of mistakes, and they want to argue they're right. 6x minus 6x is not x. I mean, is 5 minus 5 1? If you have an apple and somebody takes that apple away from you, do you still have an apple left? No, of course not. 6x minus 6x is 0. It's not nothing, it's 0. Now look at this here. This should bug the heck out of you. Does 0 equal negative 16? No, it never equals negative 16. If you get a situation, you haven't made any mistakes, which I haven't in this problem. If you get a situation of an infinitely untrue statement, 0 will never equal negative 16, there is no solution to the problem. There is no number in all the real numbers that I could put in for x and come out with an equal statement. All right, that's it. Mr. Lawrence signing off. Have a great weekend, everybody.